Good evening, everyone. We are back. Where is my monitor? Okay, everything seems fine. Let's go. But where is my docs? Bum. DirectX 3. Come here. Okay. So we found last time this that color key and stuff. Ooh, I wanna check one thing. Bitmap. Image format. So, first of all, dark. BMP, okay, I need to find a magic number. La la la, this thing. Header. File header. Deep header. Color table. Gap. There must be a special number. Two. Uh-huh. 42 4D. Is this correct? Oh, where is this thing? I forgot where I stored this. This one. Okay. No, come on. Will you move? Bitmaps, where are you? One off. Bitmaps. Um, 4D42. Yeah, so this should be correct. Let's search program text. 4D42. All blocks. All fields. Can I search at the same time? Scalar. There is specific. Either didn't find or I used it wrong. Okay. Let me see the game files and where's my hospital? Okay, we got, for example, this. Nope. Okay, they got a different format. Set handle, what is this thing? Wait for single object. Okay, so here we got this thing, and what is this? Interesting. This plus 14 is local. There's a surface. Wait a minute. Let's see this function. It will get this and this. Okay. Interesting. Let's debug it. Hey, get back. Restart. That's old breakpoint. Let's get a new one. It will be call to this for C. So let's run. And we are here. So X, this thing. It's a vtable. For C, it's this 5B62. Or 1, 2, 3, 4. Oh, okay, I'm stupid. 68 CF. Okay, that's better. So we will get here. We got ECX. It's this thing. Come on. Yeah, it's a game struct address. And second, it's this here. Which is this, where we stored our surface from the previous run. So this is one surface, and this is the second, as far as I remember. This create surface, blah blah blah. Oh my god. Let's see. Surface description, create surface wrapper, then draw result. This result, surface wrapper. Oh, this plus 18. That's where we store the surface. This param1, param1. Huh, interesting. There is a second one. So here? Ah, no. It's the first, that's the second. So at the start, at second one, at the start plus 18. So this is okay. But why second one doesn't work? It should be plus 18. Surface. Yeah, it should be right here. Why it doesn't work like that? Okay. Last time it was fine. Parapapam. Okay, let's deal with this. We again getting this thing, and apparently we will use this surface for something. Now, we are getting in. So it's F7. Yep, step into CF. Okay, this structure, this some surface wrapper. Oh my god. Step over F8. Now, this is this. Okay, I see what's happened. I somehow grabbed the wrong address. Dish. There it is. This and 1.8. Okay, everything fine. No, we got the size again of a surface description. We're locking the surface by passing lock weight. Docs the draw, please. Dark. And counter goes to +1. And we return. Surface description, LP surface. So I need a reference. Create clipper. The interface is now functions. Compact clipper surface clip. No vertical blank status. Okay. Get in there. It's pellets already. What the hell? There is a lock. Yeah, it's a part of the surface. Should be. See also lock. Oh, there it is. Okay. We are passing. This is the surface. Then rectangle. It's grab all. Description. Structure. We got only size. Event weight. If this flag is set, lock retries until lock is obtained. Or another error, such as surface busy occurs. Okay. And the last one is event handler, which we do not use. Obtains a pointer to the surface memory. After the pointer is obtained, your application can access the surface memory until the corresponding unlock method is called. Huh. There is no unlock. Pitch. Encounter. Returns immediately with an error when a log cannot be obtained. I can use wait. So okay, we are getting back the surface address, which will be basically this address. Yep. So this is the size. Okay. Push 0, push 1. 1 it's the log weight, okay. Load effective address from there. That's basically getting address of a description structure. How? Follow dump. So yeah, there is 6C. This was stored. Okay. Push. Then EBV plus 8. Oh, wait a minute, that's just a stack. There it is. That's our. Yep. Something different. Now we're getting this. That's a surface. Yep. Push EAX. Okay. And this. So EAX plus 64. Dims. And we will get apparently log function. With ECX. It's the surface. Okay. And why it's not 0? What is this address? Who knows? Okay. The XVND. Oh, is this hijacking from the XVND? But okay. Where is our structure of description? Yeah, there it is. So here we should get somewhere surface address will be this 24 to 4. So this should be, yep, that is our surface. Testing EIX. Did they okay? Pitch from the surface. This one. Yep. The OC. Then this is surface. In ECX14. This one 4 will store 18. Then UBP plus 8. Again, the same thing in UX. It's our structure wrapper. Increment the counter. EIX plus 8. This one. Okay. And then again. This one into EIX for return. And we are jumping to the exit. And we are leaving. Tish. Now we got back from here. So here we just locked the surface and incremented the counter, grabbed the pitch of a screen, basically, of a surface. I don't know why they decided to call it pitch, but how I understand it's basically width of a surface. Pitch value to get the actual location of the pixel linear. Okay, it's not this. Pitch member is valid. Pitch distance to start of next line. That's strange, but okay. Maybe it like can use the part of the width. That's why the next line will be of a clipper. Maybe because of the clipping, maybe it will happen. We will see. So edit function, lock and get surface. I need to rename this look and get surface. So it's a pointer to the surface. Then, if it's not null, we will be doing something. Let's see. We test it, and we're jumping inside this if. So YBP 14, it's again this structure. Which some kind of wrapper with two surfaces for now. So we will get YBP 14. So we will get this double word. Okay. Clean this. Then we're getting EAX to ESP plus 14. It's just local variable. How I see. This is width according to this function. One off. Because here come on. No, 10. Oh, it's peach. Ooh. The structure is freaking massive. So this 14. There is 12, 14, and this is a peach. And it's interesting. Because peach is bigger than width. Okay. Oh, peach. Then we're saving surface into another variable. So we are getting this into ESP14, which is basically stuck here. Then this YBP 1058. We are getting into ECX and this enormous thing. So plus 1058. 03, 45, F5, 16. What the hell is this? Who knows? Zero three. It's one of the tabs. Interesting. So we got this. But where is this line? It again will be somewhere else inside here. Compare. ACX plus 5. It's this. So um, um 0050. So let's go here. Plus 5. We are getting this. So it's some kind of structure. There is our plus 5. Oh my god. 1058. 1058. Of course, I can make it a structure right now. With this size. Okay. So hello, bipedal species. So we got some object inside the object, and we're checking this to 0. It's not 0. It's 14. Then we will do a loop while this UVAR is less than this 14 apparently. So yes, but then at this address of our surface which we just got. I haven't played Dim Hospital in decades. You should play it then. Did you try Core 6, which is open source clone of Team Hospital? They got a bunch of improvements over the classic one. It's not complete yet, but you pretty much can play the campaign. Multiplayer, yeah. Never played multiplayer, nor in Classic, nor in Core 6. We tried to play in classic, but for some reason it just disconnects. So the game continues, but each player is playing basically its own game. Let's see what this loop will do. Yeah, you can try a port, and if you will try, or if you will find any bugs, you can report them, so they will fix it at some point. So if this is not 0, then we will loop it until this thing is less than this. So basically it's I. So we will basically do something with a surface, because we are doing something here. Where is my surface address? I will find it later. Yes, there it is. Okay, so this should be our surface, which we will modify right now. We are getting EAX into EDX. Okay. And ESI into EDI. Source and destination are the same. Okay, EAX is -1 basically. EDX and ECX, it's a counter apparently we are doing. Yeah, because then we will get here. Increment EVX 1. Shift to the right ECX 2 times. Interesting. But this surface. Like local. Plus pitch. It's some position. You are 1. It's a pitch by 4 apparently. ECX. Oh. It's to the right. It's the divide. So we had like this. Then we got bitwise. Where is the shift? There it is. So if I will move it once, will be like that, and once more, it's a 6. So we basically got rid of these 2 zeros. We got 0, 1, 1, 2, and 4. Okay. So we divided pitch by 3, basically. Ah, no. I forgot the hex. Yeah, by 4. 2 times by 2, it's by 4, should be. Position by 4. Ah, no, pitch. Let's do it like that. And we will just populate with -1 all of this thing until for this, until it's not 0. Okay, there is reps toast. It's just to make it like per byte. Okay, it's, yeah. So we got 1, 8. All of this byte by byte should be yeah, replaced by -1. And yeah, you can see it decrements here and places -1 here, here, and here. We got all of this into -1. Then byte. I'll pitch mask with 3. What we will get? 1. So we will mask by this 2. We will get the same thing. No, mask. Everything is 0. This is 2 ones. And it'll be zeroed. So we will not get into here, because this will give us the 0 immediately. Okay, we got this and we got 0. And we will get this 0 times. So it's a compilator does this. Basically, the whole thing is to populate this X amount of bytes of, my god, yeah, bytes, because this should be the word. as efficiently as possible. So first it tries to split this x, which is 18 in our case, by like how many bytes will fit into this. So we can use one iteration like per byte. That's the biggest value you can in 32-bit system. Then it checks if there anything left and tries to push it with a bytes, the smallest one. But it didn't find anything in this case, so we will get this in one go. So all of this monstrosity is just like for loop to store this value here. Okay, nothing interesting. And then we are getting to the function. ESP14, it's our pitch. EBP, it's again this structure. And we cleaning this and moving again this 14 into AL to compare with a pitch EX and EBX. No, EBX is one. EBX is different. Wait a minute. With iteration. Okay. Oh my god, and we need to repeat this 23 more times. What is this thing? Points. My god. So we will be nullifying more. Storing -1, not 0. Okay. Okay. This increment EBX is to again 6 bytes will be cleared. We again check. So let me place this. We got simple math 18 by 6, 90 bytes in hex, so 144. But it's easier like that. 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. That's all we will do. Nope. We did a lot more. Interesting, why? If each iteration was putting 6 bytes. by 6. 50 by 18 by 3. Strange, but okay. I messed up somewhere with my math. And while this is basically 18 up till here. So 18 iteration by 6. This should be always 0. Okay, never mind. So we got the whole surface to -1. But we don't see the surface yet, apparently. Now, yes, P14. It's again our pitch. Yep. The hell? Why we lost a freaking run? Debugger. Yep. Let's go to the next breakpoint. Oh, why I can get here? Okay, entry point. Okay, now we can. Okay. We should be preparing for this call. So we again got our 18 here. Then ESP10 into ECX. It's an address to our surface, which is -1 now. Push EAX. Move again this thing into EDX. Push ECX. So we got pitch, surface. This thing which is a pointer to the structure. Where we got 18 last time. Make it again wrong. The word there is 12. Okay. and 2 zeros. 0, 0. EC contains our surface, but we pushed it here. I don't think it's this call. Because if I will try and make it this call, I will break everything. Yeah. It doesn't use it anywhere, so it's oh my god, see the call. It was shit. Redo. Now. So it's 0. So now 0, 0. It's 0, 1. Third one, some struct. Then this is our it's address of a service. Rename. But the surface. And the last one is pitch. I drew surface. Do you have a pitch also? Nope. Description. Double word. Okay, let's use double word. This one should be I direct draw surface. This one. It's a pointer. Why it's open void? I direct draw surface. And this is also. How can I tell it that it's not a copy of a surface, but just the first position of it. Just pointer. It's like a pixel. 4 pixels in this case. And in this case 1. I don't know how to explain it to Gidram. Shit. This is a surface. Okay. This is pointer. Can I make it integer pointer? Oh my god. Pointer 4. No, because the default pointer is 4. Oh my god. Int pointer. Can you use this? What is this thing? On stack plus 8. Huh. Interesting. Okay, let's go back here. Some structure plus 1. Nice. Good start. Sub push. Okay, we are getting this, which is our structure. ESI plus 4. Hmm. 1, 2, 3, 4, 5, 6, 7. Is it? +4. So again, 1, 2, 3, 4, 5, 6, 7, C, D, E. 7. Can I create a new category? Unknown. A new structure of 7D. Something like that. And we will assign this to U. But first we need to create a pointer. And now retype pointer. Unknown structure. Field 4. Here we can see that this field is a byte. Then Yesaya +4. So but this will be it seems like width and height of something. CL12 test. Okay. Oh my god, are you serious? So we got yes, I add this thing +4. We got 12. Why there's check for 5? Ah, there is bvar 0. Okay, there is this check test. Okay, this one b5. Then equals 0, we will return 1. But it's not 0, we will go here and check this to... And we will then go here. Because it's false, and we will get inside this bvar 7. And it's a field, this. And also, it's a byte. Retype to byte. Test this. If it's 0, we will fail, but we will not So we will go here. Compare this global width and height to 0. Well, this looks like a width and height also. We got 280, which is basically 640. That's what we see here. And this one is 180, which is 480. So it's height. Previous one width. Find anything interesting? Not yet, not yet. I found like direct draw surfaces on which you can draw. It's maybe handy. I don't know which one I found because from what I saw, they are pretty small. And how I read, you can have a bunch of like back buffer surfaces which combine into one and then became the front buffer. So it will be interesting to see how they did it. So from what I see here, it's a left. So it's a left top corner of a window, apparently. Let's go there. So this is this. EF4. But it's E8. What? EF4. Where did you grab EF4? Not to just make sure, but to understand how they did it and how I can use it. Because I have a plans to draw some stuff in game for myself. So I need to understand how it works so I can draw on top of it and don't break anything in the process. That's how I understand, like, it constantly overdraws everything, and if you will like inject your code in the wrong position, it will be always all written by something else, and you will not see anything, or you will get a mess on a screen. So we got EF8 here, but for some reason here it's EF. Ah, my god, because the Ghidra is showing me the different. I hate the system. There is a label, but there is the field. And when you look at this small window, I always associate it with a wrong value. I think that it is this, but it's on down here. It doesn't like move the window properly. So yeah, we are in the correct place. F8, okay. And we are subtracting x minus this. So if we get left and we are subtracting something, we will get even more to the left. And left usually it's Y. So it should be offset X. And this should be offset Y. Okay. Subtracted, and we are checking if this greater than 1. Position X. I think width, and this I think height. Oh. But why they got a byte here? Byte will can get up to 255. And it's pretty small. Or it's enough for them. Because it's a small sprite. I hope it's not a palette index. Not supposed to be. So this local will be 0 if we got position less than 1. Else, if position X greater or equal than width, we will return 1. And if it's off screen, off surface in this case. Some kind of position, okay, for now. Jump. We tested this thing. We should get here. ESP11. Wait. At 0 minus 0, yeah, we will get here. So position X is 0. Clean stuff. Then ESP34, it's our offset X again. Yeah. Move DL 12. It's a width. And subtract 0, which is our offset minus left, and then minus width, and add width. Oh my god. And we got minus something. if it's greater than 0, we will get here, but it's not. We should get here to the top. Yeah, EFC, which is also 0. ESP38, it's offset Y. Position Y. Subtract, test, assign it to 0, clean, then, oh my god, the L, 14 into here, then again, all of this nonsense. Can I rename you? EFC label. It's top. FO or document. It's a height. Label. This one F00. It's a width. No, there is. And this is the left. Yep. Nice. Now we were here. Now we getting subtraction from here. And here. Add to here. Move y by x into ESP14. Another position x. Oh my god. Wait a minute. 4, 6, 8. 4, 6, 8. So we are here. Or not. Test. Jump. ESP14. It's a stack. Okay. And then test y by x, and there is 2 jumps. Y by x. So we here. Dish. Clean. Oh, ESP11 too. Okay. Where was I? My god. Mm. And there is 487 is P11 adds position X into BL. I hate when this happens. We're doing some shit. ESP11, BL, okay. Double word, ESP14, 0. ESP24, 93. And then this in here. Bail is 0. Okay. Then add EIX plus EDI, which is both 0. And we will get this. Then 44, it's height. Subtract one from another. EDX. The L. The L, I, the I, yeah. ESP plus 2C. 0. It's our offset again. No, we are already here. I think. Divide 0 then. A4. No, we are here. Multiplication. EBPM 0. EDI 18. What we multiply and where? Interesting. Yes, 14, 0. Subtract 40. It's our surface. But it's like surface, not the interface, but real surface. Because this is incorrect. By getting this, it's not an interface, it's like real memory with pixels. Yes, this thing. And then ESP34, it's just a 0. Add plus 0. And we will get here what? The same surface address. Really strange. ESP12. ESP20. ESP18. Pointer dereference. The struct contains this. And it's also a pointer. Hmm. And we didn't get here. Hmm. And we already passed this thing. Strange. Um, mm, 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 mm. Where is the previous function? Look and get surface. So I got director surface here, but some reason it doesn't work like that. Come on, get off. Surface description, LP surface. What do you contain? What are you doing with it? Okay, LP surface, it's LP void. So this thing is not iDirectory surface, apparently. avoid. If I will go here, change this, will be different now. But my god, what is this thing? Address of the associated surface memory. Not the interface, just the memory, raw memory. Okay. Test do. Yeah. For yeah. This one. And where is it? Who knows? Come on. Get back. Oh my god. For yeah. So somehow we are here. Makes sense because do while loop will run at least once. So we're getting this ESP2C with let's assume that this is oh my god, on pre-plate. No, there is pre-comment. Go away. With equal local 10. What is local 10? It's this surface plus offset x plus position x by pitch plus this 1c. Just to get any pixel, we need to use this pitch. Pitch, it's a width, basically. So if we this pitch multiply with a position x, we will get some nonsense because it should be position y. Come on. Where is this formula? Because if you multiply pitch by y, you will get a new line each time. Like 0, 1, 2, etc. Multiplying by x doesn't make much sense. Because you will be moving the line basically to the right instead of down. What is the pitch? Where is the pitch? Yeah, y multiply pitch plus x. So why it's position x? They use the same variable. This position x left minus offset. That's okay. Offset x minus left minus with okay. But this should be position y. Why you like that? You should be like that. No. Then offset y minus top minus height. It should be y. Let's split out you as a position y. And then we should get the correct stuff. But it's still position x. What we got in the local 10 position on surface. It should be which one? Stack minus 10. There's a plus. Oh my god. So it should be second add. So yes, but 20. And because we got everyone 0, we got the first position. But because of EIX, oh, we're getting pointer from the yeah. We're getting this address plus EIX. We will get 1 8 here. 0 A 0. Yep. So we're moving to this position. current position on surface. It's EAX into ESP28. That's this. If position not 0, we will do this. AL12 EAX clean at this thing. Now we're comparing finally apparently this, and we will get in here. Move 14 to 0. Okay, then store it into stack again. Compare this to 1. Structure field 0. And this one. I want to see. Okay. Jump is by 18. It's our this structure, which is this. So it's this. We're getting from there our first thing. That's another structure with a byte as the first element. Oh my god, then we're moving this byte back to stack. This one basically CVAR. Testing. Greater than 0. We're getting in. Move sign extended. L into EAX, so in itself 0, 2. Moving this into position X, then compare again with a local D, which is the again position X at this point. Oh my god. Jump is taken. Then ESP14. It's a value from this structure which we stored. Oh my god, what are we doing here? Interesting. Then again, structure. Into ESI. Surface memory. the EDI, increment ESI. And nothing happens here for now. And then again we are storing this in a stack. Moving ESP14 again back. Okay, we saved this value on the stack, and then we are grabbing the same value and saving it back in the register. Why? Where we just took it. And now we're moving it into ECX. To the right. 2 times it will be 0, and repeat 0 times. Source destination. So at the source, somewhere here. Before, yeah, seems like it. Yeah, F7. Next one. Byte by byte, we're copying here. But there's nothing because counter is 0. Yeah, X, the ACX. It's again the same logic. How to move like 6 bytes at a time. And here we got our BD. This and this moved. So we are populating surface with something. From here. ESP18 into ECX again, our the structure and increment and jump. Whoop. Whoop. Nope. And back. We change this. Okay, this part. Decrement. Interesting. So we will be jumping around a lot here. Let's go to the exit because there's nothing else happening. And voila, we did something with a surface. and return back. To here. Good luck. You too. Okay. We are back at here. Interesting. Can our magic machine say us something? Where is my magic machine at first place? And for now, let's see this. Game struct, and it passes this. So it's not this call, it's some structure. Why it's a double pointer? Interesting. Okay, model. Which one I use? Think this one. Let's see. So we got one from here. There's a return. One. But can it return anything except one? Don't see. But anyway, we ignore the return here because we don't use DirectX register here. So move the stack, move ECX, get the function from here. It's a vtable, and now the function. And we are in this function, not this one, but this one with one param, which is this. With our two surfaces. Prepare now ECX into EBP minus 4. Wait a minute, it uses ECX, which is our game struct. Why Ghidra didn't see this? Maybe. No, it doesn't make any sense at all. It uses ECX to store it in the local variable. It looks like a fast call for me. As then calling conventions, because in this function let's get this. Come on, get the hell out of here. This is this call. Yeah, we're also saving ECX in the local. So it is this call then. Just ECX used in two cases, when it's this call and when it's a fast call. In the fast call you can pass first param as the ECX. No. Microsoft got it better. There it is. This call pushed on stack this pointer stored in ECX. Fast call. Argument to function passed in the register when possible only applies to x86. The first double word or smaller argument passed in ECX and EDX registers. Other on stack. Just it doesn't look like this call because I'm calling this function from table and the game structure. And this is equal completely different thing. I can of course try, nothing prevents me. This call. It doesn't make any sense. Then we're getting some weird stuff here. I will use fast call. So then it should be like this. But we again breaking this. Like that we don't use anything. Huh? Strange. DirectX. Okay, we saved our thing. I think it's our game structure. And it's stored somewhere on stack here. Mm. Mm. Why it's I here? My God. Game struct this. Just here we everywhere pushed our game struct. And called our function from it. Yeah, pushed it to ECX. Moved. Here. Move ECX into EBX. And we're calling from EBX plus 50. But here we got this in the ECX. The same thing. So it should be this call with one argument. Just because we never used this in the function, Gitter decided to drop it. But there is this line, which, yeah, in my opinion, is about this call. Okay. And then we're getting UBP8, which contains this thing. Some struct. Oh my god, I forgot again. For some reason I can't select pointer from this menu. Oh, do you look at that? We're checking is locked and unlocking stuff then. If this structure counter equals 0, res return -1. Else we will get first surface and unlock it. Unlock 0. Where is unlock? Notifies direct draw that direct surface manipulation are complete. We're calling and we ignore the error. Interesting. We need to pass their surface data. Address of a pointer returned by lock method. Because it is possible to call lock multiple times for the same surface with different destination rectangle. This pointer links the call to the lock and unlock method. What the second thing? And if I'm passing null, by the lock method. Let's get here. We got this, we got lock. But is this possible to give it a null? Mm. Unlock this LP void. So it can be void, so it can be null. But why there's no explanation what will happen if I will pass null? It like will unlock the whole surface. And if I will pass the address, it will unlock some rectangle. Rename locked surface counter. Something like that. Something like try unlock. Yikes, our thing. We compared this plus 8 to 1, it's a counter. And we are getting this push 0. This is again our thing. We are getting this first. Oh. 88. That's a 68. So this is the interface part. For the surface. There's 3. And a lot more. Or this is which one I can? Second one. This is our vtable for all of this. There's something additional. And this, so there's 3 structures inside. And here starts the surface itself. Interesting. The surface memory. Okay, push. Yikes again. Structure. And we're getting surface interface. And again, vtable. And from this vtable, we're getting 80, which is unlock. We got 0. And we are getting our, again, structure and the counter. Nullified, not decremented. It just nullifies it. Return 1 and leave. So we got this. Rename. Ah. I have to do it like that. Try and look. Surface. The account, what are you doing? Try unlock surface. Then we're getting this params 34, which is somewhere here. F8C, just before. Param1. Then this here, and then we are storing this inside this object. Oh my god. So if we got 1058, oh my god, unknown structure. If I will get you like that, okay, it will be not enough. Plus 4. 9A, B, C. So 1, 2, 3, 4. Okay, should be unknown struct size of 105C. What just changed and why? Okay, who knows? Read type. Pointer. Cannot modify after parameters this. Wait, pointer. If I will go up here, this, into this call. If I will, oh my god, this contains inside another this. Oh my god. This will not help anyway. I'll have to do, wait, like that. Now, what we know. This param is 1030. It's a param 2, which is a pointer to our unknown structure. Wrapper. Some. Oh my god. Hate this. Surface. Some structure with a surface. Okay. And also we know that this is a structure. Some struct. Surface rubber. Why is this broke? I don't know. 1034. X. Oh my shit. I messed up. E6, it's something here. I have no idea what the hell is this and how big it is. At best, it's F. But it may be a 5. Let's assume the big one. Unknown struct F. F. So pointer retype. UKN, oh my god, UKN, I misspelled. Can I change this? And yeah, it will change the pointer. Some struct. And this field also should be changed. Unknown struct 7 and 34 will be some struct with a surface. Struct. Why this thing changed suddenly? What I messed up here? Pointer 8. Wait a minute. ECX. We are getting to 1030 at this. ECX points to some structure. And it's a pointer. Or am I again messed up everything? It points to F8C. F8C here. Which I just created as some struct F. Then EAX is the pointer stored here. And it's our F. Yeah, 9C. That's next one, which is like that. Why it's doing this shit? Should be 4. Why it's in stack 8? Structure undefined integer pointer. Just why I don't see here. Like this thing. I will make you just a pointer. It's still in stack 8. Did I broke something? Because by debugger, this address is this. There is like possible that it's one structure with 2 fields. But then why it accessed like that? Who knows? Okay, let's move for now. We need to finish the let's get a little step back and ask our magic machine what it thinks about this function. And we will end after this. Renders a bitmap image. So my thought about bitmap was correct. RLE encoded format. Hmm. Bitmap. Okay. Two-dimensional digital images. Fixed size structure headers as well as variable size structures appearing in a predetermined sequence. Bitmap file header, deep header, extra key, bit masks, color table, gap, pixel array, gap, ICC color profile. Color table, mandatory for color depth less than 8 bits. So equal. And it's exactly our case because we got to 56, I think. And that's 8 bit. Load in memory becomes a deep data structure. In memory, deep data structure is almost the same as the BEMP, yeah, but it does not contain the header. This one. Color table can also consist of 16-bit entries. Okay. Block of bytes is at the start of the file used to identify the file. BM. That's deep header. 124. Block of byte tells the application detailed information about the image which will be used. Watch the header. All of them contain a double word 32-bit field specifying their size. Half-toning is RLE and Hoffman 1D compression. Oh. It's again Hoffman. RNC is based on Hoffman, if I remember correctly. Run length encoding, lossless data compression. Okay. So we got the RLE algorithm here. Render image stored in a custom RLE encoded format onto a destination buffer. Applying clipping against global bounds. Calculates the visible portion. The source image skip over rows above the clip area. Ah, that's what I thought. It's a clipping. Copies pixel data row by row. The target memory defined by param4. Okay. And param5 stride pitch. The function turns 1 on error or if nothing needs to be drawn. Initial check. The routine first verify that source image header contains non-zero values. Offset +1 and +5, likely with height markers. Yep. Aborts immediately if the global clipping rectangle has 0 area. Clipping calculation. How many pixels to skip? Horizontally, vertically. Row skipping, main copy loop. For each visible row, the function iterates over run length encoded segments. Okay, so this thing is encoded. This one. Positive mean literal pixel data. Negative indicates a repeat of a single pixel value. Edge condition. If the clip area reaches the bottom or right edge, the function short circuits to avoid overrunning the destination buffer. So check zero length. Okay. So this is something to do with a bitmap. Source image header is a param2. Oh no. My god, why it's so small? It's param2 or 3? Param3. So yeah, it's a structure. So it's an image header by this thing. Bit image header. 7D. This 1058 is a bitmap header. Header contains height and length. width and height. Bitmap size 14. Where is this thing? Signature file size reserved. So it's a deb header. It's not it contains this thing. Huh. There is bitmap v5 v4 headers. Ooh. This is 6C and this is 7C. So I'm off by 1 byte. If I will retype you to bitmap v5 header. And then if I will change this to the same bitmap v5 header. Bit v5 header. Okay. Okay, we found something. That's good. With height, planes, compression, and stuff. Oh my god. Okay. Okay. But why this then is stored here? If this used anywhere else, so I can verify this. Okay. Okay, the same. Null. So we use it only here. Okay. Interesting. This we can change to double word. This also double word. And what we can see. Let's see the reference to use of this thing. Oh, wait a minute. Why? $10.50. Strange 41 bytes like that. Okay. We need to understand how bitmap works here. And because basically every sprite in the game is a bitmap, should be like the core mechanic of the engine. And maybe I will understand how to hijack it. Okay, that will be all for today. I will see you all tomorrow. I hope, if everything will go according to plan. And we will play more commandos. And for today, thank everyone who survived it. Have a good rest of your day. Have a good rest of your evening. Bye bye. Bye bye, Killorian.